So these are the challenges that we tend to face, right? We've got the pressure to deliver, the business is always on our case, standardization, code base inconsistency, we've got to basically add governance, make sure that the team's acting as a single unit. There's always the tendency towards legacy, technology is getting outdated, and you can read through all of these things. These are just typical problems that we face as developers. The thing is that before I get into a little bit about how we can optimize these things, how we can mitigate these things, how we can actually find more time to spend on some of these problems, there are a few insights that I want to share with you guys. The first insight that I want to share with you guys is this. Between 35 and 85% of code-based related tasks are predictable and repetitive. Okay? They're predictable in the sense that we know, there's you could say a formula to them, and they're repetitive in the sense that we tend to be doing them over and over as we progress. And while I think once a lot of developers understand what we're talking about in this predictable and repetitive space, many of them will say to us, this is something that they've actually known intuitively. We've known this the whole time. It is something that we don't really have the tools to deal with. Okay, we kind of just have to deal with the slog. So just to understand this a bit better, I want to give you guys some examples. So let's just see. The first place that we can see this predictable and repetitive aspect to building software is in the code base itself. So a very simple example, every time you need to build a RESTful service in ASP.NET Core, I'm going to keep it .NET, obviously, because you guys are all .NET, we're going to have a lot of controllers. Okay, you guys are probably very familiar with the controller classes. And if we take a look at our system, every single controller class in the entire system is unique. Okay, they all have different routing, they have different contracts, the dispatch and all that kind of stuff. It's very, very different per controller, but at the same time, they're all the same. Okay, at least in a good system, they'll all have some element of the same. And it's really the sameness that we can call the controller pattern, because the dispatch tends to be the same. Maybe it's interface dispatch, or you're dispatching onto a mediator pattern or something like that. But ultimately, it is something that we can see is the same across all of our controllers. Another example, very simply, is the entities. Okay, entities in the system, every single one of them is unique. We've got the address, we've got the employee, we've got the client, whatever the different names are. But every single one of them in a typical system has a set of standards. Okay, we're going to be using basic properties or backing field properties. We're going to have either it's DDD, there's going to be operations. There is a formula to essentially back this, and we can call that the entities pattern. Okay, and when we take a look at this and we break it down into a criteria, essentially what we're going to realize is that these patterns essentially follow a set of implementation rules. This is what makes them predictable, okay? And they are required for every service domain in this example, or for whatever part of the system we want to build. So they are repetitive. And so we can say in this very broad sense, and I know you guys are all probably very familiar with design patterns and integration patterns and architecture patterns and things like that. The definition of pattern for this presentation today is that a pattern is anything code-based related that is predictable and repetitive. If we just zoom out a little bit and we take a look at a very typical architecture, there's our controllers, there's our entities, but these patterns are everywhere, okay? There are, this is a CQRS API, so you've got commands and queries, you've got DTOs, validators, the handlers for the commands and queries, maybe there's a little bit of domain eventing, ORM mappings, dependency injection, everything that I've mentioned there and that's on the screen right now, and so many more things in the system are essentially just patterns. These are predictable and repetitive aspects of the systems that we build, particularly in the architecture side of the system. So in all of this, there is an opportunity, okay? And this opportunity is really there because predictable and repetitive tasks yield a massive opportunity for automation. All right, so I want to jump into now what we can do about this. Okay, so we've kind of alluded to the fact that there's automation in the background. I want to introduce you to pattern reuse. So at a very high level, we like to think of pattern reuse as the missing tool in the developer's toolbox. So where the industry has essentially given us a set of tools already, we've got code reuse. That's all the NuGet packages, the frameworks, the seed works, any kind of abstraction that you may get up to in order to not have to reinvent the wheel. There's that. Okay, there's the architectures which handle all our non-functional requirements, ensure that there's good separation of concerns, make sure that we can actually build out systems that can last, okay, that can actually grow and be flexible. So there's that, and there's also the methodologies, the agile, the TDD, DDD, and all those kind of different methodologies to building out the systems. But where we find and where we reach these limits, and I don't know if you guys have how clear it is where those limits are, but just as an example, in code reuse, you can reuse as much code as you want. But you still check out your code base and you find yourself staring at 100,000 lines of code, okay? So that it can only go so far. You can only reuse so many libraries before you end up just coding out the in-betweens, okay? And so it's really where we reach these limitations that pattern reuse is the next tool that we can take out of our toolbox, and we can apply it into the software development space, and we can have a huge impact. So what is pattern reuse in a nutshell? Okay, we've spoken about patterns. If you think about all those patterns, those controllers and DTOs, commands, queries, all those kind of things that we've seen throughout our system, from the top all the way through to the bottom, pattern reuse is really the process of taking these patterns, capturing them as artifacts, okay, and then rolling them out in an automated fashion into our code base. Okay, that's really the high-level flow. But in order for this to really make sense, okay, and for it to actually work, you also need an additional component. This is the models and metadata. You need something to drive what the artifacts will ultimately yield or manifest as in terms of individual actual files in a code base that is actually going to work, okay? But what is important is that obviously understanding like why would we even do this in the first place, and that's because pattern reuse has a massive amount of benefits. The first thing is the efficiencies and the time saving. So we looked at that, we're spending 4 months. If we can just even knock off 50% of that, that's massive, okay? That means that there's a lot of other time to spend working on all those other things that we mentioned. We can go fix up a lot of technical debt, focus on maybe getting some other features out, all those kind of things. So saving a lot of time is great, okay? It means that we as developers can go spend time doing other things, or we can just work with the business to get more features out. This also brings in this idea of a free architecture, okay? And that's really because if you're taking a look at all those patterns that make up the architecture, we essentially can turn those into artifacts and automate that into our system, which actually yields a free architecture. We've got standardization, consistency, and architectural adherence, okay? This is really where you see a huge quality boost to the applications, because keeping applications consistent is pretty much what all the governance is for. That's where most of the pull requests come in, that's where most of the policing work comes, and it's something which is very, very important because entropy and kind of this progressive deterioration of code bases is ultimately what leads us to the dreaded legacy system. It's ultimately a combination of, you know, inconsistency throughout the system, entropy everywhere, stuck on old technologies, no one wants to touch it. You know that this thing's going to take me 3 days, but on a new system, this is going to take me 20 minutes. That's really the legacy system. So the standardization, consistency, and that architectural adherence is massively important. Of course, we're assuming here that the correct architecture was chosen. Codebase upgradability, this isn't an obvious one, but it's something where, and it's linked to, you could say, the legacy aspects of, you know, getting stuck on old technologies. The patterns that you have, okay, with time, those patterns are probably going to change. So you may be using, you may have built your system on .NET Framework. At some point, you're going to get up to .NET Core. But there could be breaking API changes in the technologies that you chose. And when you run into that, you can't necessarily make that change without rewriting almost that entire section, that entire layer of the code base. You probably have to rewrite it. But with pattern reuse, you can pretty much automate that upgrade. Okay, you can literally just swap from this, you know, this pattern to that pattern and move on. The last thing here, and this is really just connecting back to that models and metadata that was coming in, this is the self-documenting of the models, okay? So this essentially is those models. If you had to visualize those models, what you should be looking at is the blueprint of your system. You should be looking at some kind of a self-documentation of this is the blueprint of the design of my system at a very high level.